All right. So you work for a big company. You have a lot of people that are writing Go code, and you're using something like GitHub Enterprise Cloud, and you're using inner source philosophy. So everybody in your company is creating things, and they're being able to build. They're being able to build their projects, their Go apps, their command line tools, their APIs, their everything during using GitHub Actions, CI/CD that have dependencies on all of these effectively private repos that are on your inner source. Perhaps they're all in the same organization. Probably not, though. If you're doing inner source, GitHub Enterprise Cloud, you probably have stuff all over the place, right? You got like maybe 4 or 5 organizations, and then you figured out some naming convention to use for all the repos that are being placed into there. And then everybody in your company is being, dumped into those organizations in order to see everything within that. If that describes your scenario, this video is for you. Um, how do you create the most effective, the most easy to maintain architecture and best practice and policy for building and releasing your Go applications using GitHub Actions, GitHub Workflow Actions, whatever you want to call them? How do you do that? And particularly, using something like Go Releaser, which has got a standard action. You wouldn't have to build your own runners. Runners are containers that implement GitHub Action. There's a lot of stuff there, and there might be some things for you to unpack and go research before you continue with this video. So pause the video if you didn't understand everything I just said. Um, but if you are there and you might be stuck wondering, how am I going to build this, this critical, in our case, like, K login to log into all these machines. We have all of the credentials and login business logic is built into a single binary that we distribute to our internal people because we do on-prem Kubernetes, in addition to GCP and other things. So that's one example. That's a simple one. We're going to use that simple case study or use case to go through the different options about what you would have to do. We're not going to be showing any code here. We're just going to be talking about 5 possible approaches to getting this to work and opening up this topic for debate in the threads, because there's been a lot of feedback from a lot of really capable professionals since I started talking about this stuff and researching it. So we're going to try to summarize that today. Okay, so the first case study is, I just want to build a single binary with a private thing with no dependencies, but I want to be able to push my release. Okay, that's one recipe. The second one is, I want to be able to build an API that has dependencies on one or more other modules. We're assuming a poly, repo organization as God intended, God being Rob Pike and the rest of the people over at Go. Monorepos are an abomination that should never be used in Go. And if you need to fight me on that, we'll do that in another thread in another video. If you are using, and I don't care if you're Google, if you are trying to twist Go's arm into a monorepo architecture when it is fundamentally built on semantic versioning per repo, then you've got scripts that are removing and adding replace directives in your Go file. Another video for that. Another massive rant about that coming. I don't have that done yet because it's going to make my blood pressure shoot through the roof. Just don't do it. Okay, anyway, so we're assuming a lot of modules. So when I say you have a lot of modules, I also am saying you have a lot of repos. So you have 3 or 4 repo dependencies, and they are all on your GitHub Enterprise Cloud in your inner source, organization, one or more organizations, right? Now, the first thing you have to know about this, you probably already know this, is you now have, everything is now private. And so as far as Go is concerned, everything is now private. And this is the biggest, I want to say that this is one of the biggest, I don't know if I want to say short-sighted, examples of short-sightedness on Go. The Go module system was clearly built on Git, and it was clearly built on the assumption that everything's going to be public. And then along comes, this inner source philosophy where we're a closed organization, but we're open inside. That's inner source. And you have a problem because now, unless you're using on-prem, enterprise server, GHES versus GHEC, now when you have a server on-prem, you're good to go because you're on a VPN. Everything is effectively public. Go doesn't care where you go for that kind of stuff, and it works fine because everything's public as far as Go is concerned. But as soon as you move over to the enterprise cloud thing, now you're private effectively. So you have a problem. You can't build anything anymore. You might know about Go private and being able to build things. So now I've talked about the scenarios, and we're going to talk about 5 ways to address this problem. And I, to tell you the truth, I'm only recently coming to understanding. So if you know more about them, please let us know. The first one, the GitHub runner and NRC is that is a pat. That's a pat option. You got to put the token in there. It's got to be a pat. So the first one is probably the one that will come to most people's minds, and that's the deployment key. Deployment keys are designed just exactly like they say for building dependencies on a specific repo. And as I understand it, deployment keys are added to repos only, which means that if you added a deployment key to a repo, anything that used that repo would have to have the deployment key. Deployment keys are secrets, means you only see it one time, which means you have to have some place to put the secret, like in Vault or something, because once you see it, I don't even remember the expiration dates and timelines on the deployment keys, but it's isolated scope, but you already have read only, so in that sense they're simpler than personal access tokens, but they are, they're very, very simple, and they're per repo, which means that in order to build a CI/CD action, as far as I know, I could be wrong on this, with a dependency on that thing, your CI/CD actions would have to potentially do different things to be able to talk to the different repos. Somebody suggested perhaps a deployment key for an organization. I've never seen that. I don't know that can be done. That would be something worth looking at. But before we go down the path about whether you add a token or a credential or something to a repo, let's talk about that. So there's actually 3 places that you can add credentials. You can add credentials to the repo, right, to the GitHub repo. You can add credentials to a user, and you can add the credential. Well, there's 4 actually, and you can add the credentials to an organization. And there's one more. You can add the credentials to a GitHub app. Okay, so we're going to talk about apps last, or second to last. So those are the places where you would add your credentials. So when you're trying to think about, well, where am I even storing these credentials, and who's getting them, and how am I going to manage them? That's a big question, because depending on how you've deployed your inner source architecture for your developers, you could have 1,000 people in one organization, and it would make a lot of sense to just add a credential to the organization. But you may be dealing, as we are, with a team that is not keen, a security team that's not keen on adding a secret to an entire organization, right? Now, from a practical perspective, everything that's building any CI/CD that's using that secret, whether it's any of the options we're going to talk about, you got the issue of, is it going to expire? What happens if you have to renew it? Does everybody have to change their actions to use the new one? If it's an organizational secret, it usually is going to be a lot easier to manage. However, and this, I want to put this out there for consideration. In our organization, it is not easy to deal with the people who manage the organization. And we have, I don't like saying it that way, I'm trying to be politically correct, but it is practically impossible to get them to do a secret. And if I were going to have have them modify an organization, it would be, we would have to, first of all, we have to get them to do it. And they're already overworked, and if they're managing all kinds of different things for a different organization, and they haven't really come up with a strategy of creating a cross org credential or secret of some kind that could be used in any CI/CD in any repo across the enterprise. These are DevOpsy, GitOpsy kind of topics that are more GitHub related, but the main point I'm trying to make is that the number one consideration for which of these solutions you pick for us is going to be how easy for us is it to maintain it. Am I going to not be able to do a release until I get somebody to update a thing, whatever that thing is? Am I going to, how much management am I going to have to depend on from others versus doing it myself? And this is a big deal if you're inside of an organization that has to fight with all of these kind of situations all the time. Um, and no dirty laundry here, but let's just say there's constant dynamics, we'll say, between the security team, the GitHub team. Um, I don't mind saying that this corporate initiative to migrate to innersource has been completely derailed, and dozens, if not hundreds of organizations and projects are now asking when is it going to come back, because there's a disagreement between the GitHub team, in our case, who it's not GitHub corporate, our internal, who deployed our architectural solution, and the security team. And so the security team came to them and said, "Oh, no, you don't." And they halted the entire migration effort for the whole freaking company. And so I don't mind sharing that little bit of dirty laundry with you, because if you are in this situation, the reason that I am running this down, the reason I'm making this video, is because there's a good chance that one of you is going to find the way that you think is best for you, and it's not going to jive with what your enterprise wants. And you are going to need to articulate these options, these 5 different options, so that when it comes time to either defend your position or tell them, suggest a new position, you need to say, look, here's the work I've done. I've gone through this, and here are our options, and this is why I consider this the best option, because you're probably going to have to make your case. The chance of the people actually doing deployment, even knowing what these options are, is not entirely 100%. Let's put it that way. Uh, okay, so here, let's having done that, so we know a few things are going to have to happen, right? In order for our CI/CD to work with private repos, we're going to have to add login, essentially login credentials. That's a broad term on purpose. We're going to have to add login. We have to get it so that our CI/CD that's running, our action, our runner, has permission to see these repos. And how do we give it permission? Well, we either give it the permissions of a single user as a user and create a generic user, right? We can think of this problem in terms of like, well, how would we solve this problem if we had a person doing this? And that's a very good way to think of it. There are some, so we can think of it as like creating a generic user ID. How would we, and then give that generic user ID membership in the org, et cetera, et cetera. We'll come back to that. We have the idea of using an existing user or an existing organization and create a credential for that user or that organization that spans the organization or the user or everything that existing user has access to. Probably a bad idea to do that for an existing user, because what happens if that user goes away, right? The other thing too is perhaps an existing user has write access to some repos. Maybe we don't want that. Maybe we want our generic user to only have read access to all these repos, right? And then and that can be done through PAT or SSH, and we'll get to that. So now, and then you have this GitHub app idea, and the GitHub app idea is, you associate all the same things with the app, but then the app can be registered to and owned by a specific user or organization. I'm gonna spoiler alert. I think it's too much work to do that. A lot of people do that. It's kind of the standard thing that people suggest. I'm like, why? And I'm gonna justify that conclusion. And then there's the deployment keys. Deployment keys are access to a specific repo, as far as I know. So let's go back to our problem, right? So I pretty much already outlined all the different ways to do this, except for one. And so let's just talk about that now. If you are, and we'll review, I promise we'll review all this. Another thing that I have not tried yet is to set up a proxy. And what you do is you set up basically your own GitHub using GitHeC, GitLab, something like that internally, and you store your repos there, and then you use a proxy. You use Go proxy instead of everything else. And then anybody that wants to release anything in your internal Go environment is publishing it to this Go proxy server. Um, that has been recommended to me recently. Some of the larger organizations that are working with Go do that. Apparently, using that and then just using HTTP, um, stuff well, you wouldn't even need it because internally within your VPN, you'd be able to get to all. You're basically not using GitHub, right? For your CI/CD in that case. I mean, you are, and you would, all you'd have to do is make sure that your network connection from your GitHub is able to talk to your inner network, which pretty much every organization that's doing this kind of stuff has already worked that out. We regularly deploy to Kubernetes internally from inner source on GitHub. And so good chance that the CI/CD that's running in inner source on GitHub will have access to internal servers. And apparently, the Go proxy, setting up a Go proxy to put all of the Go projects that matter, is the way to do that. But this does not get around the problem. Okay, well, how do you authenticate what goes on the Go proxy? Who has access to the Go proxy to upload Go modules? Is somebody within the company going to gatekeep what gets put on the Go proxy? There are a ton of considerations for the whole Go proxy idea. And that's really all I'm going to talk about it because I don't know a lot about it. I haven't used it before. I know that it's a thing. It's really important that you know about it, though. We're going to come back to the other four, that being number 5. It's important that you know about it, though, because there's a good chance that when your internal Go, center of whatever excellence or something gets a hold of what you're doing, and there's an architectural decision at the highest point, there's a good chance that the Go team at some level is going to interject and say, the one best way to do this, the best practice is for us to set up a proxy for the whole entire company. You can't release a Go thing at all unless you put it on our Go proxy. And there's a good chance that they will want to do that once they find out about it. Because it does seem like it's one of the best ways to have a solution that's, for your entire organization. But then you have like siloed organizations fighting over whose proxy you're going to use. You've got a lot of other considerations about that. And so, but I think you probably need to be aware of it because it may be that some companies want you to go that way. Whether or not they force you to do it or not is a separate question. And we haven't got that far along, at least as far as I know. Okay, so let's talk about the other 4 options. And they are the deployment keys, the personal access tokens, the SSH keys, and the GitHub app installation token option. Deployment keys are per repo, as we said, and that means that you have to add a deployment key and you have to keep track of it outside of GitHub because you can never see it again after you make one. You can pretty much just rule them out. They're not realistic. Because the management of the key is so problematic that in order to have multiple projects dependent on one package, they'd all have to have deployment keys, or they have to share the deployment key. And if that deployment key changed, they'd have to make sure they get a new one, which means you'd have to have some external, storage for that's pulling it in like Vault, and then have a Vault secret, and then have that pull. It's just complicated and unnecessary. It's like crazy. So just don't even try deployment keys, in my opinion. The second one is personal access tokens. And right now, I'm just going to tell you, right now I'm struggling to decide between personal access tokens and SSH keys, and I'll tell you why. So let's rule out GitHub. Let's rule out number 4. Let's rule out GitHub application tokens. Okay. They're very precisely, they're called GitHub application installation tokens. If you hear somebody say GitHub app tokens, that's probably what they mean. And as far as I can tell from all the documentation on GitHub, this was recommended to me relatively recently. Our GitHub team recommended this to us as well. And I'm just going to tell you right now, it's not worth it. And the main reason people cite is because it has a higher rate limit than other things. This is the official way to grant access to things. And I'm like, why do you need a high rate limit for a CI/CD release? I already said this today in this video, but so the process of getting a GitHub application token is you have to get a GitHub app. GitHub apps are designed to solve a much bigger, wider scope of a problem than just giving you access to your Go private repos. In fact, that is like a tiny little fractional piece of what you can do with GitHub Apps. The GitHub Apps lets you talk to the API and do literally anything. And you can make some pretty amazing things with that. And they have advanced rate limiting on how many times you hit the API. And none of that matters. You just want to build your app. You just want access to your private repos so you can build your app. So the first thing you're going to notice when you go look at the GitHub app stuff is you're going to be overwhelmed with the unnecessary documentation, even to just do the test. You have to set up like a proxy. You have to set up a proxied OAuth, thing just to even test how to create a GitHub app. When really all you really want is that one token. And so the process is, register an app under an organization or a user that has to own it, which means you have to have a user and organization already. That means you're already in the same mess with like talking to someone to say, hey, we need to have you add a new app to our GitHub organization. Well, why didn't you have them just add a private key or something instead? So you already got that same problem, right? But in addition to that, now you have to manage, this PEM file and everything in the app in order to get it. So you've got this, in my opinion, you've got this unnecessary layer of complication between giving a credential to an org or a user in order to build repos that they own, and or repos from places that they own. So I think the app thing is bogus. And someone correct me if you're wrong, if you disagree. I don't understand where this is coming from. I keep hearing it as like that's the only way to truly do go private repos. And I personally think that the reason that that's coming that way at me is because people are used to doing this to build other projects, and they're not Go projects or whatever, right? And so I think people are defaulting to it when it may not be the simplest solution for Go. Well, let me talk about what the simplest solutions are. Let's talk about the one that's kind of obvious. You set up a generic user. This is going to be the easiest to get your head around because it's already the same thing you do all the time. The easiest one to do to get your head around is to create a generic ID, right? You create a generic ID. That's an ID that's not directly, it's owned. And it's a member of an organization or that has visibility to all of the repos that it ever could need to be. Most of the time, that's going to mean that generic user is a member of an organization, and you'd have to flag it, you'd have to track it, you'd have to see if your identity management people are going to be okay with you creating a generic ID. Some organizations have already got the architectural policy in place for using generic IDs for multiple things, whether it be a Kubernetes ID or something. They create a generic ID, it's an application ID essentially, and then they allow multiple people to administer that user. And to do things with that user. And even though it's a team, it's not necessarily it's a group. I'm calling it a generic ID. Some people call it a pseudo ID, pseudo user. I avoid the term pseudo user because somebody thought I actually meant sudo, SUDO, when I was saying it. So I say generic account. So you have a generic account. Everybody knows that generic account has is going to have limited access to things. But by default, it's no different than any other user account. And you can see how this is really easy to get your head around, right? All you're really doing is it's like you pretend like you got an intern on the team and their job is to do all the builds. It's really easy to think about and to manage in that sense. You're like, okay, we created a user account, and that user, all they're going to do is we're just going to give them read access to anything because we're terrified of them. we don't want them to have write access because they might commit a URL localhost colon 8080, in one of the URLs, which happened. Not in our company. I thought that was amazing. We do not want the intern to have write access, right? We just want the intern to do the builds and put our releases out there. So we create this generic interny kind of account. We give them only read access. So they have full access to their own stuff. But when it comes time to give them access to other stuff in the organization, we only give them collaborator read access to the specific repos that they need to see. And there's two ways to do this, right? You can manage the access in terms of the organization. They have full access to the whole organization. Or we could say you really don't have access to anything, and then we could have people grant collaborator access to that user in read-only mode for the projects that they need. This feels like user management more than anything else, because because if you take that approach, it's, you're literally approaching it like a user. How does that user then authenticate? Well, just like anything else, right? You can set them. You can any way that that user would authenticate in a CI/CD action can is good, right? So you would still, the easiest one is to set up SSH or HTTPS with a pat, however you want to do it. And then, that can access that the CI/CD can access anything that that user could access, right? And then you manage access to the different projects by the collaborator or the organizational membership, and that's how you do it. That is in my opinion, that's the easiest. We may end up going that way, but we're kind of on the fence between that and this last way, and I'll make this the last one. The last one is personal access tokens. So, and we talked about them before. I'm going to talk about them again. So, a personal access token is another way that a user would authenticate, right? You go out, get a personal access token, plop it into your GitHub command line tool, and boom, your GitHub command line tool now has access to do anything that you would do with regard to GitHub. It's the same exact thing. In fact, it's almost exactly the same as an SSH key. The only difference is that with a personal access token, you can itemize and you can really get precise with what that specific token is granting access for on behalf of the user or org that owns the personal access token. By the way, if you don't want to do, you can add a personal access token to an org, and then any user, but then you still have to have a repo that's got a CI/CD process that's going to invoke the personal access token of the org. So whether you put these things, you can't SSH in as an org, as far as I know. As far as I know, I don't think you can identify yourself and log in as an org. I could be wrong on that, actually. Okay, does anybody know? I haven't done that in a long time. I haven't logged in I've always logged in as me, and then I've been able to do stuff as my org because I'm an administrator on the org. I'm pretty sure you can't do that. Anyway, so I think it comes down to creating either a personal access token or an SSH key. Both of those, by the way, have to be stored outside, because the personal access token, you get it once and it goes away and it expires in 180 days maximum. You have to refresh it all the time. In fact, let's talk about the personal access token versus SSH approach a little bit. So the SSH tokens do not expire. They're designed to not expire. You'd have to set them up to expire on your own. That means that when you add one, it's good until you revoke it, right? And if you are going to be changed, any project that is going to have CI/CD that's going to log in as that user is going to need to access that secret. Now, as long as you shouldn't, because it's just the one user, you probably aren't going to have to mess with the secrets in each of the projects, because it's the one secret for that user and you're logging in as that user. So you shouldn't have to do that. But if you are still paranoid about that, you could still put the SSH private key in a vault secret and then create an action that pulls it in. And none of your projects would be impacted by that, because they don't have to. If you change, if your secret gets compromised or something, you just change it in Vault and everybody gets a new one. There's still the question of how do you authenticate to Vault? You've got the secret that's authenticating to Vault. How is that any better policy wise? And the consideration with Secure Shell is it even okay for your organization to have a non-expiring secret in the system? And I think the answer is yes, because if you had a user, again, back to this intern idea, the intern is not going to have to refresh their SSH key all the time. Maybe they need to be. I'm pretty sure you can't do that, but personal access tokens definitely can be set to expire. They have to be, right? But if you're setting up an SSH key, they're by nature, they're designed to work all the time. So as long as you protect the key, the private key, then you don't have the hassle of dealing with the keys. Is that less secure? Is it going to pass your security policy? That's up to you to decide. And by the way, that's with using SSH. It's just one solid connection to that, and the granularity of access is then managed as if it was being granted to the user. I think I've said that 10 times now, but it's really important. The personal access token thing is giving access to that user, but only to some things that the user can do. And this is where I think personal access tokens are going to be the preference. Without a doubt, the most common documentation about how to do this is using personal access tokens, specifically in Go using the netrc file. There are a lot of people who have tried to build in the token into the URL and modify their git config file. And I can tell you that the standard Go way to do that is to use netrc instead of that. You can definitely get it to work that way, but populating the netrc file with the credentials of the PAT is that's the easiest way to do it. If you're going to use the SSH way, you have to do a go git config line in your CI/CD action to change it, because it's not going to use SSH. And the thing about SSH that's a little hard to consider is for some reason it feels like when you're using SSH as described, you're kind of swimming upstream, because it seems like a lot of the documentation, a lot of the stuff about using actions and stuff is all based on HTTPS authentication using the tokens. In fact, you can use the GitHub token, the one that just goes per repo, per run, anywhere. I mean, you can use it in the Git address, so you can put that in netrc. And there's just a lot of the use of the token is pretty prevalent throughout all of the examples, and I tend to think that the personal access tokens are the way to go. The fundamental difference between a personal access token and an SSH token, as far as I'm concerned, is that the SSH token does not expire, and the personal access token must expire every 180 days. That is everything else kind of comes down to that, because in terms of scope and access and everything, I feel like that. Now, again, if you're using a generic ID, which you should be in this case, right, then the scope of access that is granted through, itemized personal access token is less important, because the user, unless your organization is incapable of adding a generic user with limited access to other repos, and that's the thing I'm researching right now. It's very possible that you can't do that. It's like if you add a user and it's in your org, it gets the same perms as everybody else in the org, including right access to repos that it shouldn't have, right? That would be a solid case to go the personal access token route, because at that point, the personal access token route is granted with that user, but then the access token itself can limit access for that token. And in fact, you could have several personal access tokens for a generic account that have different scoped access. And you could put those in your secrets management system, and you could pull those out, but you better be damn sure to set up alerts and stuff, because when those things expire, your entire CD's process is broke. And that is a consideration that's it's weighing very heavily on me and my team right now. If you sign up for personal access token approach, you are signing up for credential management and certificate renewal all the time. And then you need to make sure that you do that, because if it expires, I mean, there's nothing that will make a senior manager or a senior executive architect come down on your team harder than having outages because you let your certs expire, because it's so embarrassing. It's one of the most embarrassing things a senior architect or director can have their team do, and it happens all the time. I cannot tell you how many times we've had critical multi-$1,000 outages because certs expired and nobody knew they were coming up in expiration. So, it could be that your security policy says thou shalt expire everything all the time. And you don't have the choice, and that choice has already been made. If that's the case, PAT is your only option. It literally is your only option. PAT or GitHub app tokens if you want to go through that hassle. But it's no better It's literally no better. The only time you would ever use a GitHub app token is if you wanted to do something else besides just build your Go project. Like you wanted to build some sort of integration that regularly hit the API to do other things, which I don't. Um, and so that decision may have already been made for you. If instead your team is fine with stuff having non-expiring credentials, and they would rather not be reminded of login credentials all the time, then the SSH key in the generic user account seems to make a good approach. Hi everybody. I really feel like that's been a long video. So at the end of it, let's just summarize the 5 ways that you can build Go. You can build internal Go projects from private/inner source repos. The first one is try to figure out a way to get a deployment key for every repo and everything that needs it, and make sure that the build actions know about it. Very problematic. Almost nobody even recommends it. The second one is personal access tokens, fine-grained control associated with either an organization, if you can pull it off, or a user. In our case, it's easier to request a user than it is to request a personal access token on a repo for an organization. So again, organization or user, generic user. The third one is an SSH token, an SSH generic account. And that is only for a generic account. I'm pretty sure you can't have SSH login for an organization. It would have to be a generic account. I guess I realize there's a distinction there between personal access token and SSH. A personal access token can be added to a repo. To an organization. Both an SSH private key and a personal access token can be added to a generic user. But the SSH key, I believe, cannot be added associated with an organization. Help me if I got that wrong. But let me know. The fourth way is people talk about it all the time, and that's GitHub apps, and specifically using the installation token from a GitHub app to do the login. GitHub apps are bloated and well beyond the scope of just wanting to be able to get access to build. They're problematic, and everybody recommends it, but I think they're crap personally. And the last option is setting up a Go proxy, which forces your entire organization to put everything on the proxy, and that bypasses all of the inner source security that is necessary for all of the options that have an organization or an owner associated that we talked about the other 4. So if you are indeed, if you are indeed wanting to gatekeep all the Go in your organization, a proxy does sound like one of the better options. But again, there's the internal dynamics of that and what that looks like. To be fair, as I said before, I have never set up a Go proxy to do those things. I don't know what it takes to do that. I don't know what commitment in terms of infrastructure resources and internal management is required to do that. A lot of the people that are going the enterprise cloud option with innersource, they're doing it because they want to outsource all of that management and hassle. So the idea of keeping a proxy behind the VPN firewall seems kind of counter productive to the goals of using an innersource hosted in GitHub Cloud. It seems like they're kind of against. I mean, if you're going to do that, why not just host GitHub internally on a GitHub Enterprise server, right? And you've addressed the same problem. And these issues are coming up. They're pretty big issues because Go, unlike anything else, is impacted by these migrations, because the Go module system is fundamentally tied to the Git addresses of the packages. So as you migrate from enterprise server or whatever it is you're using to enterprise inner source cloud sorts of things, you already have to touch every one of your packages. Every single one has to be changed. At the very least, it has to have its new module location changed. This means you got to think about things like naming and who's going to own it, and how do issues get resolved, and where are we going to release it. These are big issues, and just knowing what the direction is and how CI/CD is even going to work is a decision I would think you would want to decide well in advance of signing up on the dotted line and saying you're going to go with an inner-source GitHub Enterprise Cloud solution, because you are, depending on how dependent you are on Go, you have fundamentally dictated a lot of instant work to do the migration to get that stuff over there. And once you go there, you can't go back, no pun intended. If you go back, you're going to be breaking everything. You're going to have to re-release everything. This is, for better or worse, this is a reality with Go. Go fundamentally depends internally within the language itself, depends on how stuff is organized in the the Git architecture, the Git repo solution that you've decided. And if you mess with that, you're talking every single time you mess with it, you're talking about a lot of work to move it, even if it's minimally just rebuilding and making sure all your systems work and making sure all the names got changed. And I feel like some of the senior architects who are making decisions about architectural direction within the company and business decisions are they're not fully aware of the impact to the Go to projects implemented in Go, because they're coming from another universe. They're coming from like the Perl CPAN universe or NPM or something like that, where there's already a centralized solution and it's just a matter of granting access to that same server and you're good to go. That is not the case for Go. When you move stuff in Go, you have to deal with it, and you don't want people futzing around with replace directives and all the stuff that they have to do to make that work. So please, please give these thoughts some consideration. I'd love to have your feedback in the chat below. I'm going to stop talking now, give my voice a rest. That was quite a bit. But thank you again for all your feedback. If I missed something glaringly obvious, I would really appreciate. Oh, hey, Merrick, how you doing? I'd really appreciate your feedback in the comment section of YouTube here, so other people can find it with this video, or in our Discord if you want, or you can come on into Twitch and do that. We're gonna go back to co-working. That's not really a rant, but hopefully that'll give some structure to the decision making that you have to make. You got to pick one. I've run this by several people, and that's it. Those are the only options. So you got to pick one.